The strange part is that the United States didn't lose this technology. It gave it away. In 2010, a small team at the University of California, Berkeley began developing an open-source instruction set architecture called RISC-V. At the time, almost nobody outside semiconductor engineering circles cared. Intel dominated PCs, ARM dominated phones. Nvidia was busy turning gaming GPUs into AI engines. RISC-V looked like an academic side project for people who spent weekends reading processor manuals for fun. 15 years later, Beijing is treating it like strategic infrastructure, and Washington is suddenly realizing the blueprint escaped before anyone thought to lock the door. Because RISC-V isn't a chip. That misunderstanding keeps showing up in headlines. It's the language chips speak internally, the instruction set that tells hardware how to process commands. Every processor needs one. For decades, most of the world rented access to those languages from American or Western-aligned companies. Intel had x86. ARM licensed its architecture globally from Britain. Even countries capable of manufacturing advanced chips still depended on someone else's intellectual property stack. RISC-V changed that equation because it was open. No royalties, no permission slips, no licensing choke point. That sounds technical. It isn't. This affects power. If the United States can restrict advanced lithography machines through export controls, countries look for workarounds. If sanctions target chip firms, companies search for alternative software ecosystems. Eventually, the question becomes uncomfortable. What happens when an entire technological rival decides it no longer wants to rent the digital foundations of its economy from you? That's the real story here. And the timing matters more than people realize. In October 2022, the Biden administration launched sweeping semiconductor export controls aimed directly at slowing China's AI and advanced computing sectors. The assumption underneath those controls was simple. China remained structurally dependent on Western semiconductor ecosystems. That assumption wasn't irrational. ASML still controls extreme ultraviolet lithography. Nvidia still dominates AI accelerators. TSMC still manufactures the most advanced chips on Earth. But underneath that visible layer, another ecosystem was quietly forming, one Beijing didn't have to ask permission to use. The Chinese Academy of Sciences started backing RISC-V initiatives years ago. Alibaba-backed T-Head began designing RISC-V processors for edge computing and IoT systems. Startups like Star5 and Nuclei System Technology expanded the domestic ecosystem further. Provincial governments began funding semiconductor incubators tied specifically to open-source chip design. Not because RISC-V could instantly replace Nvidia or Intel. It can't, at least not yet. The attraction was political as much as technical. No sanctions leverage. That's the part people missed. America spent decades building dominance around choke points, operating systems, semiconductor IP, lithography, cloud infrastructure, advanced design software. The strategy worked because modern technology is layered dependency. You don't need to control everything if you control the layers nobody can bypass. RISC-V weakens one of those layers, quietly, and almost nobody outside engineering circles noticed how quickly adoption spread. By 2023, Reuters reported that major Chinese firms and state-backed institutions were accelerating RISC-V investment, specifically because it reduced exposure to American export restrictions. European companies started paying attention too. Even some Indian semiconductor initiatives began exploring it as a sovereignty play rather than merely a cost-saving tool, which creates an awkward reality. The United States spent years warning the world about dependence on Chinese infrastructure, while accidentally encouraging rivals to build independent infrastructure underneath American systems. There's a historical echo here that I can't stop thinking about. In the 1980s, Japan terrified Washington because Americans believed manufacturing dominance would determine the future. Today, the fight isn't really over manufacturing alone. It's over standards, protocols, architectures, the invisible rules underneath global technology. Whoever defines those rules shapes the next industrial era almost by default. And RISC-V may become the first major digital standard of the AI age that America cannot fully control anymore. We'll come back to why that matters for AI specifically, because this is where the story starts getting genuinely difficult for Washington. The easiest mistake here is assuming RISC-V matters because China wants cheaper chips. That's not the point. The point is survivability. Look at how modern sanctions actually work. Washington rarely needs to blockade an entire economy anymore. It just targets pressure points, advanced GPUs, EDA software from companies like Cadence and Synopsys, high-bandwidth memory, lithography systems from the Netherlands and Japan. The system works because global technology supply chains became so specialized that a few missing components can freeze entire industries. China studied that model very carefully, probably more carefully than the West expected. Back in 2018, after the Trump administration placed ZTE under export restrictions, the company nearly collapsed within weeks because it depended heavily on American semiconductors and software. Chinese officials openly described the event as a national warning shot. Then came the restrictions against Huawei. Then the October 7th export controls in 2022. Then tighter AI chip restrictions in 2023 and 2024. At some point, Beijing stopped treating technological dependence as an economic issue and started treating it like energy security. That changes behavior fast. Because if your long-term assumption is that access can disappear politically, then open architectures become strategically priceless, even when they're technically weaker. And here's where the story gets more interesting than the usual China versus America framing. A lot of American companies also like RISC-V, not publicly in a geopolitical sense, quietly in a business sense. Western firms are tired of licensing costs too. Smaller hardware startups don't want to pay ARM royalties forever. Universities prefer open ecosystems for research. IoT manufacturers want flexible, low-power designs without legal complexity. Even NASA has experimented with radiation-hardened RISC-V processors for future space systems because open architectures allow deeper customization. That's the contradiction sitting underneath this entire fight. Washington increasingly sees RISC-V as a strategic vulnerability. Silicon Valley often sees it as efficiency. Those are not the same incentives. Last year, some U.S. lawmakers pushed for restrictions on American cooperation around RISC-V development because they feared China could benefit from open collaboration. The problem is that open-source ecosystems don't work like traditional export systems. Once the architecture spreads globally, containing it becomes extremely difficult without undermining the very innovation culture that created it in the first place. And honestly, there's something darkly funny about this. The United States spent decades promoting open technological ecosystems as a competitive advantage over closed authoritarian systems. Then, one of those open ecosystems became useful to a geopolitical rival, and suddenly, everybody started looking around the room nervously. History does this sometimes. The deeper issue is what happens next if RISC-V matures faster than expected. Right now, most high-performance computing still depends heavily on proprietary ecosystems. Nvidia's CUDA platform remains massively dominant in AI training. ARM still controls enormous sections of mobile computing. Intel and AMD still matter deeply in servers and enterprise infrastructure. RISC-V isn't replacing them tomorrow morning. But it may not need to, because strategic independence rarely begins at the top of the market. It starts underneath. Industrial controllers, smart appliances, automotive systems, surveillance hardware, edge AI devices, cheap laptops for domestic use, military embedded systems. These lower margin sectors matter because they create engineering talent, software familiarity, supply chain resilience, and ecosystem momentum. Once enough developers build around an architecture, gravity starts taking over. That's how standards wars are won, slowly, then all at once. Remember that phrase from the opening? Instruction sets are invisible languages. The country controlling those languages shapes entire technological generations beneath the surface. Most consumers never notice. They just buy devices. But underneath those devices sits a stack of permissions, patents, dependencies, and engineering assumptions that determine who has leverage over whom during a crisis. And China is no longer trying to climb that stack entirely through imitation. That's the shift I think many analysts underestimated. Beijing looked at sanctions and concluded something uncomfortable. Catching America at the frontier may take years. Building parallel systems outside American control might happen faster. Not superior systems initially, independent ones. There's a huge difference. The irony is that RISC-V's biggest strength, openness, also makes predicting its trajectory unusually difficult. Nobody owns it completely. No single government can fully shut it down. Universities contribute to it. Startups contribute to it. Chinese firms contribute to it. European researchers contribute to it. That decentralization creates resilience almost by accident, which means Washington may already be facing a problem it can slow down, pressure politically, complicate financially, but not fully reverse. And the AI layer sitting on top of this? That's where the stakes become much bigger than processor design. For a while, the American assumption was fairly straightforward. Even if China caught up in some areas of chip manufacturing, the software ecosystem would remain Western-controlled long enough to preserve the gap. That assumption made sense in the CUDA era. AI isn't just hardware. It's tooling, frameworks, developer familiarity, optimization libraries, cloud integration. Nvidia became powerful partly because engineers built entire careers around its ecosystem. Switching costs became enormous. A machine learning researcher in Berlin or Toronto could move between companies and still work inside roughly the same stack. That kind of ecosystem dominance is hard to break. But there's a detail hiding underneath the AI conversation that matters more every year. Inference is becoming as important as training. Training giant frontier models still requires massive GPU clusters. That remains brutally difficult without access to cutting-edge accelerators. But inference, actually running AI models across billions of devices, spreads outward into phones, factories, vehicles, drones, cameras, industrial sensors, consumer electronics. And that world rewards scale, flexibility, and cost efficiency more than absolute frontier performance, which happens to align surprisingly well with open architectures. This is where RISC-V starts looking less like an academic curiosity and more like long-term positioning. Alibaba's T-Head division has already released multiple RISC-V processors aimed at AIoT applications. Chinese firms are experimenting with custom accelerators attached to open instruction set systems. Researchers at institutes tied to the Chinese Academy of Sciences increasingly frame open hardware as part of technological sovereignty, a phrase appearing more often in state planning documents after 2022. The phrase sounds bureaucratic. It isn't. It means build systems sanctions cannot easily choke. And before this turns into one of those China is secretly winning everything narratives, there's an important complication. China still has major weaknesses. Its domestic semiconductor equipment sector remains behind companies like ASML in advanced lithography. High-end GPU capability still trails Nvidia significantly. Leading-edge fabrication remains constrained by tooling access and yield challenges. Even Chinese executives privately admit the ecosystem still depends heavily on foreign technology in critical areas. That's the counter-argument, and it's real. But here's the reversal that changes the picture. The objective may no longer be technological supremacy everywhere, just strategic sufficiency. Those are different goals. The Soviet Union failed partly because it tried matching the West across the entire economic spectrum. China increasingly looks more selective. Instead of dominating every frontier simultaneously, it appears focused on reducing catastrophic vulnerabilities first. Energy imports, payment systems, aviation, semiconductor design stacks, operating systems, industrial software. Not necessarily best in class, good enough to survive external pressure. That is a much more achievable target. And honestly, it's probably smarter, because resilience compounds quietly. If Chinese firms can build millions of good enough domestic AI devices outside Western licensing structures, then sanctions lose some long-term leverage even if China never fully overtakes the United States at the frontier. Remember that number from the opening, 2010. That's when Berkeley researchers started RISC-V largely as an academic alternative to proprietary architectures. The project emerged from a very American assumption. Open systems accelerate innovation because knowledge spreads faster when barriers stay low. They were right. The problem is that open innovation doesn't choose geopolitical sides. That's the tension Washington is struggling with now. The same openness that helped build Silicon Valley also makes technological containment harder once ecosystems globalize. You can restrict shipments of advanced GPUs. You can pressure allies on lithography exports. You can blacklist firms. Restricting an open instruction set already embedded in universities, startups, industrial systems, and international research communities is something else entirely, especially because other countries are watching this carefully. India sees semiconductor independence as strategic necessity. Europe increasingly talks about digital sovereignty. Gulf states funding AI infrastructure don't necessarily want permanent dependence on either Washington or Beijing. Even smaller economies are beginning to realize that technological stacks are political structures wearing engineering clothes. That sentence sounds dramatic. I don't think it is. Because underneath every AI model, every military drone, every smart factory, every autonomous vehicle sits a chain of dependencies somebody controls. The real danger for Washington isn't that China suddenly dominates RISC-V tomorrow. It's that the world gradually decides open ecosystems feel safer than dependence on any single power, including America. And once countries start designing around resilience instead of efficiency alone, the global technology map begins changing in ways that don't reverse easily. There's a tendency in Washington to treat every technology competition like a race with a visible finish line. Who has the fastest chip? Who trains the biggest AI model? Who reaches the next process node first? But infrastructure wars usually don't work like that. They're slower, harder to notice. The decisive shifts happen underneath the headlines, where standards quietly become normal before anybody realizes alternatives disappeared. That's why RISC-V matters. Not because it suddenly replaces x86 or ARM next year. It probably won't. The existing ecosystems are deeply entrenched, and inertia in computing is powerful. Entire industries depend on compatibility layers built over decades. Software ecosystems don't evaporate because a new architecture becomes politically attractive. But this isn't about replacement anymore. It's about optionality. China looked at the post-2022 sanctions environment and reached a conclusion that I think many countries are quietly reaching too. Dependence itself is becoming a strategic risk. Not just dependence on China, dependence on anyone capable of weaponizing infrastructure during a geopolitical crisis. That changes how nations think, and once governments begin prioritizing resilience over maximum efficiency, open systems gain a very different kind of value. Suddenly, good enough becomes strategically beautiful. The United States still leads in critical areas that genuinely matter: frontier AI models, advanced semiconductor tooling, high-end chip design, research universities, venture capital depth. The American technology ecosystem remains incredibly difficult to replicate. I don't think this is a story about American decline. I think it's a story about fragmentation. That's different, and potentially more dangerous. Because the internet era was largely built on shared standards shaped heavily by American institutions and companies. If the next computing era fractures into partially separate ecosystems, American AI stacks, Chinese AI stacks, regionally sovereign architectures, then technology starts behaving less like a global market and more like competing spheres of influence. We're already seeing early signs of that. Different payment systems, different cloud infrastructures, different semiconductor supply chains, and increasingly, different assumptions about who should control the foundational layers of computing itself. The strange irony is that RISC-V represents something genuinely idealistic, a collaborative open architecture built by researchers who believed innovation should spread freely. In another political era, it might have remained simply an engineering success story. Instead, it landed in the middle of a 21st century power struggle, and the blueprint escaped before anyone realized it would matter this much. My prediction? RISC-V will not destroy American semiconductor dominance. That's the wrong framework entirely. What it will do is slowly erode one of the quieter forms of leverage the United States became accustomed to holding over the global technology system. Not dramatically, gradually, then permanently. Which may explain why Washington suddenly sounds less concerned about chips themselves and more concerned about the ecosystems underneath them. Because once the language spreads, control becomes much harder to translate back. If you enjoyed this one, stick around. There are a few more small technical stories quietly reshaping global power right now, and some of them are moving faster than governments understand.